Paul Baran was a Polish-born American engineer who was a pioneer in the development of computer networks. He was one of the two independent inventors of packet-switched computer networking, and went on to start several companies and develop other technologies that are an essential part of modern digital communication. Early life: Paul Baran was born in Grodno on April 29, 1926. He was the youngest of three children in a Polish-Jewish family, with the Yiddish given name Packetswitched. His family moved to the United States on May 11, 1928, settling in Boston and later in Philadelphia, where his father, Morris Moshe Baran, opened a grocery store. He graduated from Drexel University in 1949, with a degree in electrical engineering. He then joined the Eckert Mauchly Computer Company, where he did technical work on UNIVG models, the first brand of commercial computers in the USA. In 1955 he married Evelyn Murphy, moved to Los Angeles, and worked for Hughes Aircraft on radar data processing systems. He obtained his master's degree in engineering from UCLA in 1959, with advisor Gerald Estrin while taking night classes. His thesis was on character recognition. While Baran initially stayed on at UCLA to pursue his doctorate, a heavy travel and work schedule forced him to abandon his doctoral work. Packet-switched network design: after joining the RAND Corporation in 1959, Baran took on the task of designing a survivable communications system that could maintain communication between endpoints in the face of damage from nuclear weapons. At the time of the Cold War, most American military communications used high-frequency connections which could be put out of action for many hours by a nuclear attack. Baran decided to automate RAND director Franklin Bohm's previous work with emergency communication over conventional AM radio networks and showed that a distributed relay node architecture could be survivable. The Romeyer Development Center soon showed that the idea was practicable. Using the mini-computer technology of the day, Baran and his team developed a simulation suite to test basic connectivity of an array of nodes with varying degrees of linking. That is, a network of n a degree of connectivity would have n links per node. The simulation randomly killed nodes and subsequently tested the percentage of nodes that remained connected. The result of the simulation revealed that networks where Na per ml3n had a significant increase in resilience against even as much as 50% node loss. Baran's insight gained from the simulation was that redundancy was the key. His first work was published as a RAND report in 1960, with more papers generalizing the techniques in the next 2 years. After proving survivability, Baran and his team needed to show proof of concept for this design such that it could be built. This involved high-level schematics detailing the operation, construction, and cost of all the components required to construct a network that leveraged this new insight of redundant links. The result of this was one of the first store and forward data layer switching protocols, a link state distance vector routing protocol, and an unproved connection-oriented transport protocol. Explicit detail of these designs can be found in the complete series of reports on distributed communications, published by RAND in 1964. The design flew in the face of telephony design of the time, placing inexpensive and unreliable nodes at the center of the network, and more intelligent terminating multiplexer devices at the endpoints. In Baran's words, unlike the telephone company's equipment, his design didn't require expensive gold-plated components to be reliable. This distributed network that Baran introduced was intended to route around damage. It provided connection to others through many points, not one centralized connection. Fundamental to this scheme was the division of the information into blocks before sending them out across the network. This enabled the data to travel faster and communications lines to be used more efficiently. Each block was sent separately, traveling different paths and rejoining into a whole when they were received at their destination. Selling the idea. After the publication of Undistributed Communications, Paul Baran presented the findings of his team to a number of audiences, including AT&T engineers. In subsequent interviews, Baran mentioned how the AT&T engineers scoffed at his idea of non-dedicated physical circuits for voice communications, at times claiming that Baran simply did not understand how voice telecommunication worked. Donald Davis at the National Physical Laboratory in the United Kingdom also thought of the same idea and implemented a trial network. While Baran used the term message blocks for his units of communication, Davies used the term packets as it was capable of being translated into languages other than English without compromise. He applied the concept to a general-purpose computer network. Davis' key insight came in the realization that computer network traffic was inherently bursty with periods of silence, compared with relatively constant telephone traffic. It was in fact Davis' work on packet switching, and not Baran's, that initially caught the attention of the developers of ARPANET, at a conference in Gatlinburg, Tennessee, in October 1967. Baran was happy to acknowledge that Davis had come up with the same idea as him independently. In an email to Davies he wrote, "You and I share a common view of what packet switching is all about, since you and I independently came up with the same ingredients." Leonard Kleinrock, a contemporary working on analyzing data flow, also reached similar conclusions when he developed a theoretical basis for the operation of packet networks in his proposal for a Ph.D. thesis in 1961. He published his ideas in that year. However, Kleinrock's contribution to packet switching is disputed by some, including Baran and Davis. In 1969, when the U.S. Defense Advanced Research Projects Agency started developing the idea of an internetworked set of terminals to share computing resources, the reference materials which they considered included Baran and the RAND Corporation's on Distributed Communications volumes. The resiliency of a packet-switched network that uses link-state routing protocols used on the Internet stems in some part from the research to develop a network that could survive a nuclear attack. Later work. In 1968 Baran was a founder of the Institute for the Future, and was then involved in other networking technologies developed in Silicon Valley. He participated in a review of the NBS proposal for a data encryption standard in 1976, along with Martin Hellman and Whitfield Diffie of Stanford University. In the early 1980s, Baran founded Packet Cable, Incorporated, to support impulse pay television channels, locally generated videotex, and packetized voice transmission. Packet Cable spun off Stratacom to commercialize his packet voice technology for the telephony market. This technology led to the first commercial pre-standard asynchronous transfer mode product. He founded Telebit after conceiving its discrete multi-tone modem technology in the mid-1980s. This was one of the first commercial products to use orthogonal frequency division multiplexing, which was later widely deployed in DSL modems and Wi-Fi wireless modems. In 1985, Baran founded Metricom, the first wireless Internet company, which deployed Ricochet, the first public wireless mesh networking system. In 1992, he also founded Com21, an early cable modem company. Following Com21, Baran founded and was president of GoBack TV, which specializes in personal TV and cable IPTV infrastructure equipment for television operators. Most recently he founded Plaster Networks, providing an advanced solution for connecting network devices in the home or small office through existing wiring. Baran extended his work in packet switching to wireless spectrum theory, developing what he called kindergarten rules for the use of wireless spectrum. In addition to his innovation in networking products, he is also credited with inventing the first all-way gun detector. He received an honorary doctorate when he gave the commencement speech at Drexel in 1997. Death: Baran died in Palo Alto, California at the age of 84 on March 26, 2011, due to complications from lung cancer. Upon his death James Thompson, the president of RAND, stated that our world is a better place for the technologies Paul Baran invented and developed, and also because of his consistent concern with appropriate public policies for their use. One of the fathers of the Internet, Vinton Cerf, stated that Paul wasn't afraid to go in directions counter to what everyone else thought was the right or only thing to do. According to Paul Sappho, Baran also believed that innovation was a team process, and he didn't seek credit for himself. On hearing news of his death, Robert Kahn, co-inventor of the Internet, said, "Paul was one of the finest gentlemen I ever met and creative to the very end." Awards and honors. IEEE Alexander Graham Bell Medal, Marconi Prize, Nippon Electronics Corporation C&C Prize, Bauer Award and Prize for Achievement in Science, Fellow of the American Academy of Arts and Sciences, Fellow of the Computer History Museum for fundamental contributions to the architecture of the Internet and for a lifetime of entrepreneurial activity. National Inventors Hall of Fame, National Medal of Technology and Innovation, UCLA Engineering Alumnus of the Year, Internet Hall of Fame. References. External links: Paul Baran invents packet switching, www.livinginternet.com. William Stewart. January 17, 2011. Retrieved March 31, 2011. O'Neill, Judy E. Oral History Interview with Paul Baran. Minneapolis, Minnesota, Charles Babbage Institute. Retrieved March 31, 2011. A 44-page transcript in which Baran describes his working environment at RAND, his initial interest in survivable communications, the evolution of his plan for distributed networks, the objections he received, and the writing and distribution of his 11-volume work on distributed communications. Baran discusses his interaction with the group at ARPA who were responsible for the later development of the ARPANET, Harris, Trevor, who is the father of the Internet. The Case for Donald Watts Davis, retrieved July 10, 2013, Ryan, Patrick SSSRN Wireless Communications and Computing at a Crossroads, New Paradigms and Their Impact on Theories Governing the Public's Right to Spectrum Access. Journal on Telecommunications and High Technology Law 3, 239 ISSN 1543-8899. OCLC 66137086. Retrieved March 31, 2011. This describes Paul Baran's development of packet switching and its application to wireless computing. Convergence, Past, Present, and Future. Paul Baran addresses Cable Labs, a registered trademark winter conference. Louisville, Colorado, Cable Television Laboratories, Incorporated. February 1999. Archived from the original on May 25, 2011. Retrieved March 31, 2011. A transcript of Baran's keynote address at the Countdown to Technology 2000 Winter Conference that includes a photo. Brown, Bob. Paul Baran, Internet and Packet Switching Pioneer, is mourned. Framingham, Massachusetts, Network World, Incorporated. Retrieved April 2, 2011. Baran credited with inventing packet switching in 1960s against military backdrop, Paul Baran. Internet Pioneers at ibiblio.org. Chapel Hill, North Carolina, School of Information and Library Science and the School of Journalism and Mass Communication at the University of North Carolina at Chapel Hill. November 6, 2005. Retrieved April 2, 2011. Gilder, George. Inventing the Internet Again. Forbes ASAP 159, 106 Euro 120. ISSN 1078-9901. OCLC 173437996. Archived from the original on April 10, 2006. Retrieved April 8, 2011.